With number 9, we have the function f of x is equal to x to the 4th plus x squared minus 2. And we want to find out when f is increasing, which means we need to know when f prime is positive. Alright, so we're doing a first derivative test here, so we have to find f prime of x, and that's going to be 4x cubed plus 2x. Alright, and we're going to set that equal to 0. And when we do so, we can factor out a 2x, leaving us with 2x squared plus 1. And when is that equal to 0? So now we have a product which is equal to 0, so we cover them, each of the pieces up one at a time. 2x is equal to 0 when x is 0. So that's one of our critical numbers. Now we cover up the 2x. 2x squared plus 1. When is that equal to 0? All right, well, we want to think it might be something like this negative 1 over square root of 2, but hold on a second. Think about this for a second. X squared think of the graph of x squared. There it is. Now what do we do with it? We double it, which makes it narrower. Hold on a second, let me get a different color. All right, here's 2x squared in black, and then we bump it up 1. So now we have, this graph is never equal to 0. So this is our only critical number. So when we make our number line, we only have 0. We can check out something like negative 1 and positive 1. We're going to plug these two numbers into the original derivative, the first derivative. So when we plug in negative 1, we have a negative, and we know this is always positive. So we have a negative times a positive. Negative times a positive is a negative. When we plug in 1, 2 times 1 is a positive. This is always positive. Positive times a positive is a positive. We're interested when f prime is positive, so that's this region right here, 0 to infinity. So the answer is B. All right, number 10. This time we have the derivative given to us. We don't have to find it, and we're being asked when is f decreasing. All right, so that means we want f prime less than 0. Okay, so we need some critical numbers. Well, right away I can see that if x is equal to 0, we're dividing by 0, and the derivative will not exist. So x equals 0 has to be one of our critical numbers. Well, what else do we have? Well, let's see. We've got x squared minus 2 over x is equal to 0. There's a couple of ways to solve this. You can turn this into x cubed over x. Right? X cubed over x simplifies to x squared. All right, minus 2 over x. Right? And then now that we have a common denominator, we can put that together. That's equal to 0. A rational expression is equal to 0 whenever the numerator is 0, right? 0 divided by anything will be 0. So we really need to find out when does x cubed minus 2 equal 0. Well, that means we're just going to add 2 to both sides. So x cubed is 2, which means x is equal to the cubed root of 2. Maybe that's part of the why we see these two numbers right here as potential answers. Okay, so there's our second critical number. Okay, so we're going to place these two on a number line. Now I don't know what the cube root of 2 is. I know it's positive. Right, so it's definitely going to be to the right of 0. But exactly how far? Well, let's think about this for a second. I know that 2 is between 1 and 8. The cube root of 1 is 1, and the cube root of 8 is 2. So this is going to be a 1 point something right here. So for my test values, I know I'm safe by picking 1 here. I want to pick a bigger number over here, maybe like 4. All right, and then I need a number less than 0, so maybe like negative 1. So there's the 3 test values. We're going to plug these into the first derivative. So if we plug negative 1 in here, we have negative 1 squared, which is 1. And then we're going to have 2 divided by negative 1 is negative 2. So we have 1 minus negative 2. All right, that's a double negative. We see that's going to be 3, so that's positive. Now we plug in 1. If we plug in 1, we have 1 minus 2, that's negative. And if we plug in 4, we have 16 minus a half. 16 minus a half is definitely positive. So we're interested when f prime is negative, and that's going to be from 0 to the cube root of 2. So the answer will be C. And just quickly, in case you're wondering what's going on here, the parentheses, because we can't have 0 be part of our answer, since that would cause the division by 0. So open bound, or open, bound with the 0, but closed with the cube root of 2. That's fine. If they'd done the open with the cube root of 2, that would have been okay as well. All right, last but not least, number 11. We have f double prime. When does the graph of f have inflection points? All right, well, inflection points, that's going to be when f double prime changes sign. We talked about that already in an earlier problem. So we cover these up, right, because we're setting this equal to 0. So we can see that x equals 0, x equals -1, and x equals 2. -1, 0, 2. All right, so we pick some test values. All right, if we plug in -2, we have a negative here. -2 plus 1 is -1, so that's negative. -2 minus 2 is -4, but it's squared, so the square means this is always going to be positive. So I'm going to change that to put that in black, because it's always going to be positive because of that square right there. A negative times a negative times a positive is a positive. Now we do -1/2. -1/2 is negative. -1/2 plus 1 is a positive. Negative times positive is a negative. There's an odd number of negative signs. Now we go to 1. 1 is positive. 1 plus 1 is positive. 1 minus 2 squared is positive. Positives across the board. That's going to be a positive region. And finally, we pick 3. Positive, positive, positive. There we go. We want to see f double prime change signs. Changes sign right there at x equals -1. And it changes sign right there at 0. Positive to negative, negative to positive. -1 and 0 is the answer.